From the Spec Network, this is Fragmented, an Android developer podcast where we talk about building good software and becoming better Android developers. I'm Donn Felker.
And I'm Kaushik Gopal.
Welcome to the show. Today's episode of Fragmented is brought to you by Mapbox. Mapbox is the location data platform that enables developers to build experiences for understanding and exploring our world. Mapbox's various Android SDKs make it easy to add global location data and context to your Android project. And that means SDKs for beautiful and performant digital maps, global driving, walking, and biking directions, and other location tools such as location search, meaning geocoding or reverse geocoding, which is awesome, retrieving and managing device location, geospatial analysis. And here's the thing that I really like about it, because every single time I've tried to use maps in my application, my maps look the exact same as all of the other apps, and I would like them to be styled a little bit differently. The cool thing about Mapbox is they offer complete map design control. They allow you to create beautiful custom maps to meet the design needs of your app and your Android users. If you're like me and you want to give this a shot, I recommend that you go to mapbox.com/Android. Again, that's mapbox.com/Android. So do yourself a favor, join thousands of companies and hundreds of thousands of developers who have already integrated Mapbox into their Android project. Visit mapbox.com/Android to get started. For those of you that are just joining us on this journey here, I think it's important to note that very early on in the Fragmented podcast history, Kaushik and I decided that it would be a good idea to attempt to cover all of the items in Joshua Bloch's seminal work, Effective Java. Now, at the time when we made that decision, Effective Java version 2 was out. Now, just recently, very recently, as of this recording, Effective Java version 3 has come out. Now, a lot of questions are we going to continue doing the course, or staying course to the original podcast, or are we going to deviate, or what's the thought process behind this? After some deep looks into the content of Effective Java 3, we decided to continue on. Now, and what I mean by that is we're going to continue the Effective Java series. However, there's going to be some changes in regards to that. I think it's important to note that some of the items in Effective Java have changed. Now, we're not going to go back and recover the existing items we already covered, as it would just kind of be repeating ourselves over and over. And the reason for that is though some of the examples and some of the things may have changed a little bit, the concept is still the same. But what we are going to do is there are new items that have been added and also inserted into random indexes that were not there before. So for example, item number 5 in the version 2 does not match item number 5 in version 3. So item number 5 has had a new item inserted in the version 3 of the book, meaning that this item in version 3 was not there in version 2. So what we're going to do is kind of, as we encounter the ones that were not there originally, we will insert them as we run across them. So immediately starting off, instead of starting off where I would have started off, which is I think on item 17 or 18 at this point, I'm going to actually rewind back to item 5, which is a new addition to the version 3 book. So without further ado, let's hop right into it. Item number 5 in the Effective Java version 3 book is Preferred Dependency Injection to Hardwiring Resources. Now, this one's actually going to be quite simple for us to understand because dependency injection as Android developers is something we're all very familiar with. Prior to Dagger being around, there was actually Juice and RoboJuice, and that was the first dependency injection framework that I worked on and helped contribute to. But now everyone seems to use things like Dagger, and there's also some Kotlin ones coming around. And so we're very familiar with these, so this should be pretty simple to understand. But let's go ahead and hop right into what it means here. And the example that Joshua gives here is you may have a class that may need to depend on a spell checker. And this class that you may be writing, you could be writing something like a nice edit text that allowed spell checking for you. That's a very real use case that you could find a use for this. Now, typically, prior to dependency injection, someone may actually go ahead and create a spell checker that's kind of a static utility class. So meaning that it has a private constructor. You cannot instantiate the class. All the methods are static. So you may call in a word saying, hey, is this a valid word? Or what are some of the suggestions for this typo that I've passed in? And you may call that from within your class. Now what this does is actually tightly couples your actual implementation of the spell checker to whoever is using it. So that tightly couples those things together. So if something breaks, it could be more difficult. Or, in this case, if you would like to actually replace to have different types of spell checkers because of, different languages and special vocabularies or special dictionaries, well, it would be hard to replace that spell checker. So it would be great to actually inject these types of dependencies. And furthermore, and this isn't really talked about here on item 5, is to actually help with the use of testability and making sure that it's really just decoupled. And I really like the testability aspect here, because when you are injecting something through a constructor, and especially if you're relying on an abstraction like an interface, what you can actually do then is easily unit test this. So if I have a class that depends on a spell checker and I'm going to pass in an interface for maybe a spell checker interface, at that point I can then, using a mock or whatever I want, or a test double, I can say, all right, well, when this is called, I want to throw an exception, or I want to return these values. And then I can test all these different scenarios in real time using all the known, result sets that I may be working with. So for me, that's a humongous win. It's equally as important as the actual decoupling, in my opinion, especially for statically based languages like this, such as Java. Just being able to do that is fundamental, in my opinion. And so one of the things that Joshua really highlights in bold here, and if you're reading the Kindle book, it's actually kind of nice, and that's where I read it. It actually shows you the areas in which are highlighted more and more and more. This is one of those sections, and it says here, I'm going to quote, it says, static utility classes and singletons are inappropriate for classes whose behavior is parameterized by an underlying resource. So again, we shouldn't be using anything like a static class. We should try to inject it via a constructor. And so the funny thing is a lot of folks, if you're not even using dependency injection, or you even know what dependency injection is, and there are a lot of folks out there who are still becoming interested in it and still learning about it. And if you're one of those folks, don't feel too intimidated right now. It's actually a very common pattern. You're just passing things in through a constructor in this instance. There's also other types of dependency injection, which is not covered here, such as method injection and field injection and so forth. But the concept is the same. You're providing some type of dependency and is being injected into a particular resource. And here is using the constructor. Personally, I prefer the constructor injection primarily because if I'm creating a class, I know everything that this class is going to need when I'm building that class. Let's say I want a new instance of something, and it tells me, all right, well, to new this up, you're going to need this service and this repository and these two other things. I then immediately know, okay, I need those things. Where do I get them? And if I'm using a dependency injection framework such as Dagger or Juice or Spring or anything like that, then I can have those supplied for me much easier than actually having to wire them up. Because again, if you need a huge object graph, having to instantiate that yourself every time can be quite painful. So a lot of folks will end up using this. You can also use this in a method kind of like a factory. So if you want to pass in a resource factory via your constructor, you're still doing dependency injection, and that factory may actually, which is called a factory method, which is also referenced here from the Gang of Four patterns. It's just how you can use a supplier of T, which is available in Java 8, to actually build out your factory with a parameterized type and using a bounded wildcard type. That's a whole other story in itself, which relates to item 31, which we'll get to. But long story short, dependency injection is going to improve your flexibility, your testability, and as I said before, yes, it can seem like it's going to explode your classes or your files, and it's going to clutter up things that can feel like a time. And when folks start using this pattern, that's what they feel like. Wow, I have this interface, or I have this abstract class, and I have this other thing, and it's being injected into here. And before I had 2 files, now I have 10, and etc. And I'm just kind of rolling with the punches here, but you can kind of see how it just feels like you're creating more stuff. But eventually you do run into the scenario where, like, hey, I need to test this. And you realize, hey, I don't need that actual network. I can actually, provide a test double for that network, or I can provide some type of mock for that network or that database or whatever, and it makes it a lot easier. And you can use tools like Mockito and stuff like that. And furthermore, it just decouples your dependencies. So in summary, what this item number 5 states is to don't use a singleton or a static utility class to implement things that you need, which you can actually use through dependency injection. So if you're calling something inside of your class and it's a static method somewhere, is there a way that you can actually inject that into your class? Is there a way that you can actually pull that out? One of the things you're going to run into a lot of times is maybe a third-party library. And this isn't covered here in the book. This is kind of just things I've experienced. You're going to have a third-party library that is actually has a ton of, implemented as a singleton or as a static utility class where you're just calling these methods on it to return values. And you have no control over it. Maybe it's actually writing and reading from a file inside of a cache. You can't control that. So usually what I like to do at that point is create a wrapper around that. So some people call these wrappers. Some people call these like delegation. I've even seen them have coined the term, which is by Jean-Paul Boudhou from probably a decade ago, which I think was called the static factory or something like that. So there's a bunch of different names that these things go by. Long story short, you're just going to wrap that and then inject that into your class. And then at that point, you can actually replace the guts of that thing if you need to, and just makes it a little bit easier to enhance your flexibility, reusability, and testability of your class. So again, we are covering item number 5, prefer dependency injection to hardwiring your resource. If you haven't picked up Joshua Block's Effective Java version 3, I highly recommend going and picking it up. It's updated. Again, probably one of the best resources out there. Even if you are actually out there writing Kotlin, you have to understand that underneath the hood, it's all the JVM. So these concepts do matter to us. And you actually see a lot of these things implemented in nice advanced languages like Kotlin as well. And you'll see them referenced inside the documentation. So having a good understanding of, hey, item number 32 or whatever they're talking about in the documentation is key. So please do yourself a favor, go pick up a copy of the book and we'll put a link in the show notes. Thanks again, folks. Before we dip on out of here today, I'd like to say thanks again to our sponsor for today's episode, and that's going to be Mapbox. Mapbox is that location-driven platform that enables developers to build experiences for understanding and exploring our world. Like I said before, you can customize that map to your heart's content. If you're interested, go to mapbox.com/Android, and they're going to hook you up.
That's it for the show, folks. Fragmented is hosted by Donn Felker and me, Kaushik Gopal. We edit and produce all the episodes here on Fragmented. Sarah the Amazing Jackson from the Spec Network helps with production assistance and wraps our final mix. Our theme and ad music is by the national recording artist Blueprint from Weightless Recordings. You can find more Fragmented episodes at fragmentedpodcast.com. Thanks for listening, and we will catch you in the next episode.
Thank you.